My name is Stephe HZB. I'm from the Netherlands. I received my bachelor degree in physics at the Utrecht University. And after this degree, I found that I wanted to apply this knowledge in the field of renewable energies. And this made me pursue to obtain a master in energy science, also at the Utrecht University. Since I think that the solar energy has an enormous potential, I found it very interesting to continue to broaden my knowledge in photovoltaics, and therefore I did my master research also in this field. During my master research, I investigated the implementation of metallic nanostructures in thin film solar cells, as well as the fabrication and also the characterization of these solar cells. I feel that solar energy in the future will become a strong component in our range of renewable energies that we can use as an alternative to fossil energy. And of course, when we want to produce solar cells on a large scale, it's important that we use materials that are non-toxic and also earth abundant. In addition, it's also important that we can use this technology for a wide range of applications, and therefore we also need to focus research on thin film solar cells. I think that the KESTcell project is a very nice opportunity because it really covers all these arguments that I also find very important. Personally, I find it very interesting to explore new materials and techniques, as I also experienced during my master thesis or master research. And what I also noticed there is that it's really important to have certain techniques that are able to really control and monitor the processes that you use for your fabrication of your solar cell. And this is basically the main motivation that I wanted to pursue a PhD at the Helmholtz Center, which is focused on this development of these techniques for process control and monitoring in this new material that we're using, kesterite. In my work, I will focus on the implementation and development of optical techniques for in situ process control. This is important because we would like to gain information about the material that we are growing and that we're fabricating during the process. So information such like phase transformations, surface roughness, thickness of your material, these are all things that are important in the end for the quality of your absorber and therefore also the quality of your solar cell. In the first thing I will investigate as in situ optical techniques, reflectometry and Raman spectroscopy. So during the fabrication of our absorber, it's important that we know the influence of the process parameters that we use. So the most important ones are temperature and pressure. And what we are going to do as well as in situ optical techniques to control the process, we will also analyze our material afterwards in order to compare it with what we measured in situ and to see what we have gained in our material afterwards with ex situ characterization techniques, such as electron microscopy and also XRD, to analyze the morphological properties of the material, also the compositional homogeneity of the material, and also the structural properties of the material, which are all important to know and which in the end also determine the quality of your absorber and in the end also the efficiency of your solar cell. We should have gained more control over our processes so that we can obtain better absorber quality, which in turn should also lead to solar cells that achieve competitive efficiencies. I expect that we can achieve our goals in the KESTcells project because we are working together with different groups and institutes across Europe. Of course, there's overlap between these groups, but each of the groups also has their own expertise. And the so-called secondments, so the research visits that are an opportunity for us as early stage researchers, really gives us the possibility to benefit from the equipment and the knowledge at different partners, and also to share knowledge actively together and collaborate together in order to gain the best results. For example, during my secondment at IREC Barcelona, I was able to learn about ex situ Raman spectroscopy and implement this knowledge during my secondment at the Uppsala University, where I performed an in situ Raman spectroscopy study on kesterite synthesis. In addition, several industrial companies are involved, And this means that we also have the opportunity to take the requirements for industry into account, and therefore we can also bridge the gap between research development and industry.